Looks like Sirius might be picking stuff up.
Bottoms
well,
in
that's
sight.
good news for a few of the later dives, I think.
Yeah, there
There
is.
we go.
Patty,
Again,
this,
that will
Scott,
still
you
be...
asked about a biological perspective.
Wow.
Coming down.
I would say that from the standpoint of the Cecil communities, it's nice to be going up these steep slopes, so that'll be interesting to see. And then to move along the edge of that upper part of the ridge. We are deeper than we were yesterday, and so I would anticipate, like yesterday, that densities will be low. There should be diversity down here, but I wouldn't expect that we'd see all that many animals. Hopefully we'll see some interesting ones.
There you go.
And my prediction will be that we would see more sponges than corals, although there are certainly corals at this depth, and we should continue to see some interesting mobile fauna.
Well, folks,
and Scott, we ought to be on the lookout for some new recruits like we saw yesterday, too, for the corals. Okay, go ahead, Patty.
I'm just going to say we are seeing the bottom, and it is a beautiful,
cool. Very interesting.
scarp.
Really interesting.
Hey guys, just to follow up on Chris's comment, Chris, yes, we can do the eastern-facing features, but that will very much be current dependent on each of the days, so it's going to be something we'll need to call on the morning of.
Right.
Current looking.
Okay. Well,
I understand. Thank you.
does anyone
would you
have
like me
any
to,
other
tilt down?
comments or
you're gonna have
questions
to.
regarding
I'm having
the
to back
plan
up,
for today?
Keep away from the wall here as I get down.
Well, sounds good to me.
And then
Okay,
once
so
we get there,
why don't we
make
go
a
ahead and do
note
our
or a
intros
point
then
on
while
my
we're getting
sonar
ready
just so I
to
can
get to the bottom? Yeah, Patty, go ahead.
keep watching this.
We just had a question from Roland as to whether we should put up the image of the seafloor for you now rather than the map on your view, because it is really pretty.
Yeah, let's just do that.
Thank you.
Just go ahead and do that. It's really interesting.
Thank you.
That's great.
Thank
it's
you,
going to
Roland.
move closer for a little bit, but
I'll move it back.
Okay, good morning, everyone. Hello again to those of you who have been on for a few minutes. We are aboard the NOAA ship Okeanos Explorer, which is America's ship for ocean exploration, and we are coming to you live from the Mariana Trench National Marine Monument. My name is Shirley Pomponi. I'm from Harbor Branch Oceanographic Institute, Florida Atlantic University, and NOAA's Cooperative Institute for Ocean Exploration Research and Technology, and I am the biology science lead on board this leg of our mission, and I am joined by
Patty Fryer. I'm a marine geology professor at the University of Hawaii, part of the Hawaii Institute for Geophysics and Planetology on the Manoa campus of the university on the island of Oahu.
So while we're getting in position, I just wanted to let you all know that this mission is designed and supported by NOAA's Office of Ocean Exploration and Research. You'll hear us call it OER. And the ship is operated by NOAA's Office of Marine and Aviation Operations. Our current expedition is part of a 3-year campaign, and the acronym for that campaign is called CAPSTONE. So you may hear Chris Kelly call it CAPSTONE. CAPSTONE stands for the Campaign to Address the Pacific Monument Science, Technology, and Ocean Needs. And this campaign was designed to address the need of resource managers, so these marine monument resource managers, to better understand the deepest parts of our nation's marine monuments. Other NOAA partners in this effort are NOAA's National Marine Fisheries Service, the Marine National Monuments Program, the Deep Sea Coral Research and Technology Program, and the National Center for Environmental Information. We'll tell you more about each of them, as well as our other academic and research partners in a few minutes. One of our other important partners is the Global Foundation for Ocean Exploration, and GFOE operates and maintains our vehicles, the Deep Discoverer and Sirius. And as soon as our ROV crew gets comfortable, we will have them introduce themselves as well. Right now, what I would like to do is have our shore-based science team. As mentioned, Patty and I are your ship-based science leads, but we have a shore-based science team who's very important to this mission, and I would like to have each of them introduce themselves, please, and we will start with Chris Kelly.
Hi, I'm Chris Kelly. I'm the program biologist for the Hawaii Undersea Research Laboratory here at the University of Hawaii in Honolulu. I'm serving as the science lead and, well, mostly the science advisor for the Office of Ocean Exploration and Research during these Pacific cruises.
So we're about 20 meters.
Could we zoom in on that sort of orange stuff?
Okay, well, I'll try to remember that.
Yes, I'm Bruce Mundy. I'm a fishery biologist with the NOAA Pacific Islands Fisheries Science Center, and I'm located at the Hanoi Regional Center for NOAA in Honolulu, Hawaii.
Actually,
my role has been to try to identify the fishes that are seen during the dive.
Not like Zoom.
Deb Glickson.
I'm still setting up.
Hi, I'm Deb Glickson. I'm here at Harbor Branch Oceanographic Institute, part of Florida Atlantic University, and I was the geology science lead on Leg 1, and I'm also the associate director for the Cooperative Institute for Ocean Exploration, Research, and Technology.
Thanks, Deb. Do you have anyone in the ECC with you?
I will be joined by one of our interns, Nolan Barrett, in probably about 15 minutes.
Great, thank you. Scott France?
So you're looking straight down at me.
Yeah, I've just been hanging out over here.
I'm at the University of Louisiana at Lafayette. I'm a deep-sea biologist, and I am particularly interested in the deep-sea corals and really looking forward to this deep dive.
Great, thanks. Tara Harmer-Luke?
Hi, this is Tara Harmer-Luke. I'm also a deep-sea biologist from Stockton University in New Jersey. And my area of interest is chemosynthetic organisms at deep-sea hydrothermal vents. Bacteria and things that can use chemicals to produce their own food.
Thank you, Tara. Debbie Blaney?
You seen any
Okay, I don't
other
think Debbie is on the phone line right now. We also have two additional deep-sea biologists who are joining us on our chat line. One is Asako Matsumoto, and Asako is from the Chiba Institute of Technology in Japan. And we also have Tina Molitsova from the PP Shirshov Institute in Moscow. So is there anyone I missed?
Actually 40 meters in front of
okay, let's yes, Bruce.
I just want to give a shout out here. There's somebody else here at the IRC who doesn't
I don't think we should move back at all.
Wade Higuchi is one of our IT technical support people. And Wade and a couple of other people here put an awful lot of effort into keeping these command centers up and running, putting up the different displays,
or are you happy with
responding to different requests, displays when needed. And I think sometimes it's not appreciated how much effort goes into running the command centers, getting them set up and keeping them going. So even though Wade won't say anything, I just wanted to give him appreciation.
Adjusted at all?
Great, thanks. I think that goes for our IT teams all over the place, including those here out on the ship, too. So thanks very much. Let's see. Is our ROV crew in a position where they want to introduce themselves yet?
Yeah, you bet we are.
Okay, cool.
Okay, kia ora, everyone. I'm Jeff Williams. I'm your pilot here this morning for about another hour yet.
Wave to the camera.
Hi, camera. To my left is Sean Kennison, navigator. To my right, Andy Lister, co-pilot. Over in the corner, Roland Bryan, video engineer. In the back row, Annie is doing our clipping for us. We're all from the Global Foundation for Ocean Exploration, and we are really excited to be out here exploring today. This is unknown territory.
Okay, let's dive.
Our pilots, I imagine they're almost set up now to start moving up
We are.
the slope. Folks, you've got three potential views down on the bottom of your screen. The one on the left-hand side is the high-definition video from the remotely operated vehicle. There's a big camera right in the middle, and what happens is the pilot will arrange the ROV in the perfect position for zooming in, which is what our videographer Roland will do. But if you look at the second, the middle of your feeds, you can see a picture from the Sirius vehicle, which is above the ROV on a 30-meter tether. and it is looking at a nearly vertical scarp with beautiful grooves in it from probably erosion, maybe faulting. And then the ship is up above us, that is the ROV.
So I think what maybe was happening when D2 had its forward way
talking about
us
as the ROV, but okay, oh man, if you look in the main view, we are looking at this wonderful scarp of what looks to me like maybe layered.
That's what I think, maybe at least, because you can see you were really
volcanic sandstone.
Yeah.
So we're looking northward.
Straight north.
That's north.
The remotely operated vehicle's heading is visible in the quad screen, which is your third
I've been watching it. I haven't seen any movement.
The screen, the feed over on the right-hand side on the bottom. And there you can see
Pilot,
the upper left the video image. On the bottom left,
if you could
the navigation, in other words, the bathymetry map, and where the ship is, and the little white thing is the ROV. On the top right are the positions of the ROV and Sirius. And also you get the depth of both vehicles. And on the bottom right you see two circles, and these are showing the sonar images.
Southwest.
Oh, and I just see that Bob Carney is also joining us. Bob is from Louisiana State University. Hi there, Bob. Great to have you.
Now, is he with Scott or separate?
I'm ready for some guidance here. What would you like
Okay, we would like to move up the slope.
Thank you. You just stepped onto a minefield there, Patty.
Whoops. Excuse me.
Okay, moving up.
Coming up.
Any rock samples from
Actually, that was Shirley.
Take a view of the
I don't know,
crinoid.
pilot. We see I think that is a crinoid to our left. I'm wondering, pilot, if any of these chunks of rock look like they might be loose enough to grab. These might all be stuck, but it's likely that they're sedimentary, and it's likely that they might be kind of soft, might be pluckable.
Okay. That's like pick-upable?
Pick-upable.
Yeah, but
thing.
maybe kind of, it's awful steep slopes, so they might, if you do loosen them, they might go rolling down the hill.
Okay. I see one to the right of the crinoid. I'll look at that after we take
That looks great, yep.
Okay. Zoom.
Did I hear someone on shore? Crinoid. First critter.
Yep.
Yeah, you can see there's a little bit of current that's pulling me to the south.
Ah.
Okay. There's also a very small coral immediately below the lasers.
Yeah, Roland, can you zoom in on that a little bit, please? A little bit more.
Well, I'm certainly not moving any closer to the cliffs.
Okay,
I've been watching it really closely.
Zoom in the coral. Going back to the crinoid.
So it'd be interesting to see if this crinoid is attaching itself to a rock in outcrop or a boulder on the slope.
Roll into the crinoid.
Okay, let's look at how it's attached.
Oh.
There you go.
Now that looks like it's in place to me.
Sure does.
That material, that rock is part of the outcrop. So that crinoid's been there a while, perhaps.
Deb thinks we might be able to pick something off of the outcrop. She's not sure how much it's in place. Yeah.
Well, there is loose stuff in the lower
Andy, are you
left.
Okay, so we need to make a decision about that because we don't want to stay in place for too long.
The pilot said that there was a rock to the right of the crinoid, so we want to look at the crinoid and the coral first.
I'm way off to your left now, and I'm feeling tether tug.
Okay.
It must. I mean, I'm not saying you're moving, but
you can see white streaks through this outcrop.
I've been feeling like it has because it looks like on video, but I mean, my sonar hasn't changed.
Fracture filling.
I'm not really sure why it looks like that.
Quite sure how we're gonna.
What would the
I might be able to give you some tether. Would you like me to come down just a little bit?
If
interpretations.
I mean, you're at a 55.
If it's layering,
that'd be
then
great.
this could
So
be,
That would
interestingly
probably
layered,
quite a bit.
you know, not horizontally parallel layers. But my gut feeling, kind of hard to tell unless you can get out there and measure things, you know, is that these are
there you go.
fractures in the rock that have been infilled by later materials of some sort. But the rocks that we're looking at right now look as if they're actually in place, but possibly, you know, broken up enough so that perhaps the pilot can grab either the one with the lasers on it or the one to the right.
Get a good reference here.
So, pilot, do you think the one just above and to the right of the lasers might be easier?
Yeah, that's something right here in this picture I'm thinking is what we're going to try for.
Deciding which one, huh?
There we go.
We just bring the jaws out and try to grab something, see if it wiggles.
Yeah, probably grabbing rather than, you know, testing it, which might
Yeah,
dislodge it.
For you.
Yeah, if I test it, gravity will give
do
us
its
the
thing.
answer.
For
sure.
Look erroneously green, so I'm going to try the other preset.
Okay, copy that roll.
I'm ramping up your hydraulics for you.
Okay, copy hydraulics.
Preset 2 days ago.
This slope is so steep that I cannot imagine that this these couple of
Nav,
rocks
if you would,
in
could
the
you move that
bottom center of the screen
just along the cliff
are
on my
not
sonar?
in place.
So I see
Yeah, absolutely.
down the
Appreciate
bottom
it, thanks.
skid.
And that just means that we will actually be sampling the formation or the layer of material from
Perfect.
which this sample
Thank
will
you.
come.
No problem.
We hope. Just a moment ago, the sample boxes in the front of the remotely operated vehicle touched the wall, and a little bit of the material was jiggled loose and kind of flowed down the side in a cloud. So it's got a very fine, sort of ground up surround around all the blocks of rock that we're looking at. Oh, wow.
Okay, that looks stable.
Okay. You want me to bring up Mini?
Um,
Or is it not really going to help?
I can't.
Can't rotate it.
I can't rotate it. Right now, I think I'll just try to work with my manip cams and this.
Okay, you just holler if you need me to change the screen.
All right. Hydraulics up?
Hydraulics are up.
Okay, thank you. Arms alive.
So the pilots are going to put on some additional cameras so that they can get a parallax view as they approach this rock. That helps a lot, because otherwise you're just looking at it in one, basically 2 dimensions, so just a flat screen. Little red dots are 10 centimeters apart. That's about 4 inches. This is about a 6-inch diameter rock. Very loose material around it. Oh, it is moving. It might be a little larger than I thought.
That's a big rock.
Oh, look at our pilot.
Gonna start a rock slide.
Wow. Wow. Landslide. I think it's good for a rock box, but I'm not so sure that rotating it is not going to drop it. What do you think, pilot?
Yeah, I'm thinking we just go straight to the rock box. Could you bring the
starboard right.
wing in, please?
Starboard wing coming in.
What would you like to call this?
I would like to call this possibly a rock. Possibly
I got that far.
Possibly a sedimentary rock, but we'll find out. Maybe we can change it later if it turns out to be something really interesting.
And why isn't sedimentary rock interesting? All of those sedimentary geologists out there might be inquiring.
Actually, it would be interesting if it were ash in this could be dated. it would have maybe these little shells, tests of one-celled organisms, maybe foraminifera or nanofossils.
Okay.
Put the rock box away.
I am impressed.
Rock box heading outboard.
That was beautiful. Thank you, pilot.
That was a little bit bigger than we thought.
Yeah, I agree.
We'll let Matt pull that one out.
Looks like a biological thing near the claw. Just up
and
right of
that
lasers.
was at. Depth. Our
Can you get
depth
the pilot
is
cam on the arm? I don't quite have something right yet. Oh no!
Oh, you just want it over there?
Yeah, just
okay.
Steer that to the. Oh, there we go. That's better.
Let's see, is Josh entering these data in for collection for nav?
Josh, when you have a moment, I wonder. Yeah, could you put in the?
That wasn't Josh. That's not Josh. That's Sean.
Oh, sorry, Sean.
Yeah, never mind.
Okay.
I don't think he does. I don't think he enters it. I think Josh does.
Okay.
Radio.
Hydraulics off.
Pilot, before you.
That heat is causing me to look like I'm moving in towards there, but.
Yeah, co-pilot, I got visual on you. You look pretty good. I didn't see any movement.
Okay.
A little bit of oscillation, but you're not.
Then I'm going to lateral to the right before we go up.
Okay.
So that I get more in line with you.
Okay.
Right now, this isn't ideal.
Pilot, before you pull out, I'd like to show the top right-hand corner.
Top right-hand corner.
Where's our depth? What happened to my depth?
It's not available because they're using this feed for.
Okay, hold on. I'm going to switch over here.
No, it's not going to work. I just switched over to the multi-view, and that's what's on.
the rock with the browns.
We can't even do it with the scroll locks. Sorry, everybody on shore who's listening to this. We're just trying to figure out our keypads here.
I think it was just
Video. There we go. No, I can get it.
Yes, the stain. I was.
I don't want multi-viewer though.
No,
I can't get.
Okay.
How about that? Okay, readjusting.
There we go.
419.
And there was
4419 meters.
Near the base of that crinoid.
Well, actually, I'm not going to go back there right now.
Yeah, that's fine.
I'm going to come back over here where Sirius has settled out.
Okay.
So, watch lead pilot.
Go ahead.
Yeah, you know we're 4,400 meters deep, so there's a lot of wire out, and so again we've got this situation where we can command the ship to do something, and then about a half hour later,
it happens. Right.
Yeah. So I think what we just observed there is Sirius was still settling out, and when I made contact with the bottom, so I'm having to sidle to my right to get back in line with Sirius, and then we'll continue up once Sirius is pointed upslope again.
Oh, that's fine. This gives us a great view along contour.
That's a bonus. Yeah.
I got a pretty good shot over here on Sirius too, if you want to see it from above.
And if you need me to stop and look at something, just say.
Okay. Keeping an eye out for critters. Looking for critters.
Okay, I'll start to turn towards slope.
And so we see a little tailless chute, which
feel better.
Probably is in a region of faulting in these rocks that is weaker. So when material slumps down the hill, it tends to grind away on the exposed rocks and make little valleys.
A good direction here. Whoops.
There's a bit more sediment.
And I'll come back down for you.
On this slope, obscuring the outcrop.
Something red center screen there, Rolly. Is that?
Yeah, that looks
Looks
like
like staining. Yeah, it's staining.
But you never know.
I'm going to call it biological staining.
Every time we zoom in, we see something biological. That's what makes it fun. So this is at 4414. Generally the same sort of blocky looking, heavily fractured exposure.
Some white dots on the right, maybe sponge, small sponge material.
Yeah, I'll come up on these that are in front of me.
I don't really see distinct layering in this material.
A lot of sediment, huh?
A lot of sediment here, yeah, not so much in the previous slope.
Yeah, where we first landed.
This looks like it's a little less steep.
Slightly out.
So they're like buttresses and shoots, buttresses and shoots, where you would see kind of like flows of sediment.
Yep, exactly.
Okay,
Shoots and ladders.
For them to go out right now?
Yeah, that'd be fine.
Okay.
A little bit higher is the white dot. Yep.
Yeah, these chutes are probably fault controlled. Oh, do we have, there's something white there. What is, no, it's just staining on the surface of a rock. But we have hydroids growing on the surface of the rock,
possibly, yeah, possibly.
Huh.
And that rock left is off screen.
As we get closer in, okay, it does look, the red that you see on this looks like the fresher surface of that silty vitric sandstone or siltstone, and then the black surfaces look like they have that very thin manganese oxide coating. Last night I took a look at one of the rocks from the previous ridge and tried to measure the thickness of the manganese on most of the little fragments I knocked off the rock. It was about 0.01 millimeters. So,
hey pilots,
yes sir.
Would you be comfortable if I started putting in short moves,
very,
like
very
a 10
thin
meter
manganese coating?
move at 0.1?
I'm pretty
might
close
not see
to
it
that right
for
now.
20 minutes though. Might be 20 minutes till you see it. So 10 meters would still put you in front of serious sonar.
It's going to make them start moving at shift change. So do you think maybe we should?
I can just wait. Yeah, I mean,
it's kind of up to you guys. I'm just pointing out things.
Yeah, I'm good with a 10 meter move because we've got 10 meters of slack easy.
Okay.
So.
All right. Start. And then.
Pilot, are we going to zoom in on this white layer?
Yeah, let's go for that, Rolly.
Thank you.
I'll just make it due west. That looks pretty good.
Yeah, I'm facing due west, so.
Partial.
Okay, hold that.
See if there are any barnacles on this.
Patty's really into barnacles. I just did a search and sent her some. She wanted to learn more about barnacle morphology. So
barnacle anatomy.
So she is going to be our barnacle. She's going to be our barnacle narrator for today.
Oh, I have to go check out your email though and pull that picture up. Wow, that is different stuff in here. This is what's probably filling fractures. I have no idea what it is, but it's really pale.
So Les Watling said that one of the things he likes to do is look around on land for analogs to what he sees, what he's seen in his dives on seamounts. And he said that this place looks a lot like Diamond Head, especially the location where the rock was collected.
That's interesting.
Interesting.
Well, I'll let you know, Les, whether it's fine-grained material or all full of little cinders and blocks and things that got spewed out of Diamond Head. But I certainly know what you mean. It's the right color as we're driving around the front of Diamond Head up to the lookouts to watch the surfers and the windsurfers down there in the water. Oh, there's a white something.
It looks like it's more that.
You think it's a little piece of rock?
It looks
hard to tell unless you get real close. I think it is just it's just a surface on the rock. So mostly what we've seen so far are these little sort of hairy things on the surfaces.
I'm not sure what those. I mean, they may be hydroids. I can't tell.
Wonder if we can get close enough to look.
I don't know. Can we? Yeah. Is it possible? Is it possible to get a closer zoom on those?
The hairy bits?
Yeah, the hairy bits. Yeah,
okay.
The hairy bits.
Just tilt down and find something close. There you go. Just
sure.
to the left. Oh, wait a second. Hang on. I'll go down even further.
Yeah, Tina Molotova is just not thinking that these might be
on the bottom right.
Hydroids. Remember a few days ago we saw. It was actually about a week ago. We saw kind of stringy stuff hanging down, and we just were not. No, I don't think it's hydroids.
So a little bit over. I wonder, pilot, if you can get over to the right where they're a little longer, or maybe up just a little bit where they're long enough that maybe we can tell what these things are.
Is that full zoom?
I did.
Oh,
max
thanks.
zoom.
Oh,
you got
wait,
something
there's something
up.
standing up. I think that's one of your carnivorous sponge things. You think?
I have no idea. It looks kind of.
It's very. It looks like it has a core, though. It has a stalk, and then there are things spread out from it.
Yeah, it does.
It looks fuzzy.
It doesn't really look like the carnivorous guys, but it is fuzzy. But it is.
The fuzzy thing is a holothurian.
You're kidding.
Well,
Roland,
I can't tell.
Roland is saying it's a holothurian. We need to get really close to see that guy.
Okay, for what?
I think he's less than a centimeter long.
Oh, my.
And he's going from bottom to top.
Yeah, you're right. Roland's saying it's going from bottom to top. So
meaning bottom is the mouth? Is that what we're going to get into this?
No. On this
Bottom
one,
of the
never
rock.
be able to tell.
Okay.
And I'm going to take a guess that the top is his head because I saw two translucent, what would on an insect be an antenna.
I'm going to have to come over and look at his monitor.
Roland, our videographer, has the best monitor, so he often can see things before we do.
Where is a little?
Not only can he see them before, he can see them way better and has a much more discerning eye.
I think it may be to the left.
Yeah, I've lost the rock he was on.
Yeah. Oh, rats. Yeah, I've lost the rock too.
I thought it was.
Let's take an inspection of this guy.
I don't think it's that one. No.
There's one.
There.
Polychaete.
What?
Polychaete to the
bottom edge
lower
of the
left.
screen.
Yeah, that white thing.
Nope, to the right of the white thing.
To the right of the white thing.
I see it. Center screen. Just 3 o'clock, just off center.
Yeah.
It is just slowly moving.
There's a polychaete slowly moving
that is
on the surface of the rock to the right of the center.
Oh, yeah. Yep. Yep. Over there.
That's good.
There.
Yes, I see it.
I thought you guys were talking about that.
No, the thing with the legs.
Yeah, I see it. Cool.
Little white polychaete. We often see these in the water column.
We did see some. Actually, we saw some yesterday.
But where is the little holothurian?
We lost it.
That may have been it. It looked like about the same size.
Okay.
It was only a centimeter long.
Yeah.
So
pretty tiny.
Still good.
Hey, Nav. When did you call that move-in?
Science. So, question. What happens to the rocks that we collect?
Copy.
What is their future?
The future of rocks that we collect, like the one we just picked up, is to go to the Oregon State University curation facility there. And all of the rocks, in fact, all of the samples that we collect, whether they be rock or biological, will be available to anybody who is interested in working on them, you have to submit a request, explain what you want to do in terms of work on the samples. And these samples will be available relatively soon, much sooner than if this were a federally funded, like National Science Foundation funded thing, which has a moratorium of a couple years.
Couple years. Yep. And the biological samples go to the Smithsonian. So we preserve them according to an established protocol. So we preserve them, put them either in ethanol or formalin or in a special fixative for molecular work.
Right.
The samples that we preserve for molecular work go to the Ocean Genome Legacy at Northeastern University. And as Patty mentioned, there's you can submit a request for samples or data to Ocean Exploration and Research, OER, at the Ocean Explorer website. You can submit that request and indicate what you'd like to do,
right.
Purpose for evaluating the data or the samples, and then you can get a decision will be made, and you can get access to the material.
Right, actually, we did.
So here there's a 10-meter move-in. I guess I'll hop up and see what's ahead.
Would you like to introduce yourselves?
We didn't.
Yeah, we just had. Yeah,
we didn't mention that all the rest of the data too, the bathymetry data, the nav data.
Yeah, they're introducing themselves now. Yeah, yeah.
So we just had a watch change. That is the ROV pilot, navigator, and the co-pilot are new.
Yeah, even though we just got on the bottom a little while ago,
they've been here
since about about 4.5 hours.
So I can know when I'm moving.
So they just made a shift change, and we're going to go ahead and
10-meter move.
Introduce them.
Crew 2, not meaning they're second, but just second today. Not that they are
7 minutes ago.
The B team.
Not at all. They're fresh, aware, and ready to go.
Yep. Okay.
Yep. We put the A team for driving around on the bottom, actually.
Oh, yes, of course.
B team does the launch. So.
Okay, so
I'm kidding. We rotate every day.
Okay. Go ahead, Carl.
So I'm Carl McCletchy. I'm the pilot for this watch for the next
wave to the camera.
3 hours.
Here we go.
I'm part of Global Foundation for Ocean Exploration, a team of engineers who we operate these vehicles, but we also designed and built them, do all the maintenance.
Continually update them.
Yes.
Add new bells and whistles.
Yep.
Absolutely.
Okay.
Every
and a
winter.
Scoop next year.
We'll add something. Put in your requests.
Okay.
And to your left?
To my left, we have the navigator.
Ooh, beautiful. Serious.
Open your mic.
There you go. Richard? Is that Richard?
Looks like I'm starting to move here a little bit.
Okay.
Okay, after some minor mic adjustments. My name's Richard Stoner, and I'm your navigator for the next 3 hours.
Hi, Richard. And where's Levi?
And I am Levi Unema. I will be your co-pilot today. We might experience a little bit of turbulence due to the waves.
Yeah, it's a little lumpy on the surface
here. Should be a good flight.
Thanks, Levi.
Yeah.
And we still have Roland over to the...
Way in the corner. Roland Bryan, a video engineer, and also
our videographer.
For the Global Foundation
An
for
award
Ocean
winner,
Exploration.
as well as a really nice guy.
Wait, and who do we have in our back row?
Tara Smithy. I'll be clipping for a while today.
What does that mean?
We clip out all the video that has anything audio-wise or video-wise that we want to save, and then archive it.
Kind of hard to
select. And it's all public domain
Looks
as
like
well.
Kind of hard to select, right?
Starboard
kind of
is
hard
all
to
the way
select
right.
highlights when you have something.
We end up saving a lot.
Move them outboard.
Yes, it is hard.
Looks a little bit
Select the highlights.
Actually, I guess
But if you go to the website,
move
you'll
them
find
right and left
films
respectively, and
from
then
the
deploy them
various
just a little.
dives
Try to get
of some of the coolest things
Just going
that we saw
outboard
that
more?
day.
Yeah, just a little.
Okay. Port outboard.
Okay, so if you all at home take a look
I see they're
at
already down.
screen 2. Is that
Yeah,
on screen 2?
feed 2 is
No,
the
their-
Sirius
their
view,
angle's good,
and
sorry.
you can see a
Do you
beautiful
want
image
starboard
of
inboard
this
a little bit?
ridge, essentially, that we are going up.
Inboard.
On the main screen,
But that just
we're
aimed it more
seeing
at the
nice
crest.
layering in the material, so very likely sedimentary exposures here.
So Sirius is another remotely operated vehicle, and it is tethered to the ship, the Okeanos Explorer, by several thousand meters of tether.
What'd
And
you see
then
for
the
a delay
Deep
there?
Discoverer, what you're looking at, is
9
tethered
minutes,
to the
10
Sirius by about,
So
what,
you
about
started
30
thinking, right?
meters?
Yeah.
30
about 30
meters,
meters to
right.
tether out right now.
Yeah, I would expect it to be longer than that.
We've
This kind of
seen,
reminds me of what we were seeing at Hadle Ridge.
Yeah.
it does look
It's pretty
somewhat similar, although
Do you
the
have a
white
sonar
that we
mouse?
saw at Hadle Ridge was huge, thick layers, and here we're seeing what looks to me like fracture filling, but it could be carbonate.
And the person who was just talking,
We
who
should
tries
introduce
to
ours.
keep hurting
Okay,
all of
let's-
us cats out here is.
Minutes since the last
Hi, I'm
move.
Casey Cantwell. I'm
Are
the
we
expedition
happy with
coordinator for
a
this
10-meter
cruise.
move?
And she's
I
doing
work for
pole position
NOAA's Office of Ocean Exploration
for 5
Research.
minutes.
And if her boss is listening, she's
Or
doing
every
an
10
absolutely
minutes.
awesome job.
Totally
Thanks, guys.
awesome.
Marvelous job.
Well, Levi was
Working
looking at the
many,
timing. He
many
thought he
very
started
long
moving
hours.
10 minutes after the move started.
Thanks, guys.
Yes.
And then
Casey
it
doesn't
takes, I
seem
guess,
to
a few
sleep.
minutes.
No, she doesn't.
Looks like I got a video only. I'd have
Well,
to
she
do.
has multitudinous
Oh, that's
tasks.
okay. Now
She's
I'm going to adjust it.
Coordinating between
we'll just
not
go
only the
basically by
science
Sirius'
and the
sonar.
ROV,
The ground
but
is
bridge
25
crew,
meters
ship's
away,
crew,
so we
in
could
a
probably
variety of
do
ways. Tough
a
job.
30-meter move.
So the way this
the
this
Sirius
expedition, this mission operates is kind of unique. All of our operations are science community driven, and they're carried out on behalf of the
negative.
entire
We're gonna have Navigator do that
ocean
for us.
science and,
Thank you,
and
Roland.
resource management community, as opposed to being driven by the questions of one particular principal investigator who gets funded to do a research mission. So through telepresence, the technology that's making what you at home are seeing and hearing right now, making that all possible, we're able to have dozens of scientists engaged in an expedition, so more than we could ever fit on one normal research vessel. So right now we have about 20 users in our chat room, in addition to a few others who are on the phone line but may not necessarily be in our online chat room. So for example, I mean, Patty and I would normally have never had the opportunity to go on a exploration mission together, and nor would I have probably ever had the opportunity to work with, say, Asako in Japan, or Tina
in Russia,
right, or even Tara Harmaluk in New Jersey. So this gives us an opportunity to really put these best minds of the experts in a variety of disciplines, all of which focus on these the Mariana Trench, geology and biology, and enables us to really get a comprehensive look and description of these environments and their communities.
See on the right-hand side of the screen.
So we'll take a 30
these
meter.
box of some sort.
A bearing, last one was at 270.
Yeah, that looks pretty good on
What are you
the
saying?
Sirius
What are you
sonar.
saying, Roland?
Yeah, 270.
Patty and Shirley, this is
And
Bob
keep speed to
Stern.
point one.
Can I make
Hey.
a comment about the rock?
Hi, Bob. I'm sorry.
Just with the
Could
delay,
you
that
repeat?
Doesn't matter too much, but yeah.
I wanted to make a
Right, can you rotate right and look at the edge of the rock?
Suggestion?
We're,
Sure.
setting up our move here. Video.
Go ahead.
So, in the,
So yeah, I don't know if
this is obviously a cluster section.
how long does that move take at point 1 versus point 2? That's a good question. You have your
Everything above
calculator
the
up there.
three-height is pretty much volcanic. And these things fracture like old volcanics, probably Eocene volcanic. So I'm guessing, you'll tell me whether or not I'm right when you get a chance to look at the sample, that these are some of the 4R igneous rocks, the fab that we talked about, or the bonanites, or something like that. But it could possibly be prototypes, but
10
I think
minutes
we're
to 5
too
minutes.
shallow to be in the prototypes. That'd be exciting.
Yeah, I do too.
Something to think about.
Yeah, absolutely, Bob. And I will let
we
you
could do the
folks
point
know
one.
what that rock is. I promise. Yeah, I'd love it to be an igneous rock, as I told Shirley when we picked it up.
We're happy to call that in.
More sediment. We got plenty of sediment
I'm ready.
at Stegosaurus Ridge.
Bridge from
The
that.
the rock that we picked up earlier in the dive Were you online when we did our first sample, Bob?
Right of way.
Sure.
Yeah.
Okay.
Bridge
You have
from
a really blocky fracture, which is the way that metavolcanic series could possibly
you can visually see the stuff is very crumbly.
Can I ask for my first move of the day, please?
Old volcanic.
We would like a
And to me, it's
30
like an
meter
incredibly steep
range.
cliff.
Yeah.
At a bearing of
Okay, but that's
270
They're
and a
basically
speed of
vertical,
0.1 knots.
They are.
This must be the effect of subduction, erosion, and massive landsliding. Huge chunks of crust falling into the trench
Cool looking.
over the.
Absolutely. I think that's very true. The shape of the structure that we're diving on, this ridge, is oriented not exactly north-south, but there are hummocky bits of topography at the base of it, which very clearly look like a slump deposit of some sort.
Hey, Bob, this is Shirley. We're hearing you really well on the audio, sorry, on the telecom line, but it's apparently very quiet on the video feed, so some of the folks at home may not be hearing what you're saying. So if you can just speak up a little louder, please.
Sorry, Bob, I didn't realize this.
Video
just
pilot.
for people at home who do not know who the Bob
Having
is that we're talking to, this
same
is
trouble as
Dr.
usual. I
Robert
can't-
Stern, and he is
If I turn
a
OKEX to a
professor
normal
of geology,
level without
a
blasting
rock
my ears from the
specialist,
back row, I
also
can't hear anyone on shore, so-
specialist in tectonics, and he's from the University of Texas at University of Texas Dallas in Richardson.
Okay, guys, so since we did call in the move and it'll take a while, I won't just hang out here. I'll look around.
But I think right now Bob is in Taos,
And then
so he's
nobody will
calling
really
in
know
on a
that we're
phone
waiting
line.
for the ship. And we'll cover more ground.
That's true.
So I'm going to go...
So he's real close to my husband's sister, who is living just outside of Taos. So wave westward, Bob.
So what was that red stuff that we just saw going by?
The red stuff that we saw going by was a staining on the rocks. I have no idea what it was.
Come up to it.
Sorry. We saw some of that yesterday, too, on Stegosaurus Ridge, and just little patches on the rocks.
So, folks at home, how are things working out with the speed that we're going? We were, as Patty and Shirley mentioned this morning, we were trying out something a little bit different than yesterday for our procedures for moving the vehicles in the ship.
Yeah.
How is that working out?
Okay, pulling you out full wide.
Okay. Yeah, when you have a chance, can you adjust the gains on my sonar so the brights aren't so washed out?
Ooh, lots of tailless. So right now we are looking up one of these chutes, or
I think it's if you left click, you can adjust the little yellow line to be above the yellow.
valley
And if you
features
right click,
in
you
the
can
rock
adjust the top end
face.
to be above the red.
Survey one. Could you
And these
maybe
are probably, like I
have a
said earlier,
conversation with that
probably
person that was
fault
quiet before?
controlled, and therefore sort of a weak place in the face of the scarp, that when there are earthquakes in the area and anything moves, rock material may fall down the slope, and it will bump into the things that it hits, and so it tends to erode more readily in those areas that have already faulted and broken up. The other thing you can see pretty prominently in the screen right now is all these white streaks
try right-clicking
through the
dragging
outcrop.
in the same bar.
And
Inside the
these
color.
are very likely secondary deposits of something.
it's a
We wouldn't know
left
until we
drag out
could get some
To
of that
get
material back
the
on the
yellow
ship.
line to move.
But fluids perhaps
Yeah, to go
moving
up now.
through the
Up, not
outcrop
down,
can
up.
carry
Yeah.
dissolved constituents and redeposit
there.
them in cracks, fractures
So
in
that's
the rock
yellow
phase.
line.
And do we
Well,
have...
you guys can figure it
That's
out.
not a shrimp. The red thing in the water column. Nope.
There it is. Yeah. There it is.
Piece of a salp.
So, Bob, would you be able to talk a little bit about what these sort of white, they look like stripes are on the mountain?
See, the yellow's good. It's
Or
just
not
barely
the mountain, on the wall?
touched by the yellow bar, yellow line. And then you could probably drag the top down a bit. Leave the yellow line where it is and drag down a little.
Some kind of an alteration fractures. They seem to cross each other. They're sub-horizontal, but I think it'd be nice to look a little closer at some of them.
Yeah, that's perfect.
Once we get a chance. But to me, they look what we call secondary.
So you have the hang of that now?
After the rocks were formed.
It's only, if you're in the color, you can only
Bob,
right
I
click
think
or
you're absolutely
click and
right.
drag.
That's what I was wondering.
Only 4 options.
Some of them are
Up or down,
horizontal,
left or
but
right.
there also are some at high angles, cross-cutting one another, as you mentioned. And I've seen some that are essentially vertical, paralleling some of these big chutes where the talus is coming down. Now you can see on the right-hand side of the screen now some of these are at about a 45-degree angle in the face of the rock that we're looking at. It's kind of amazing.
The other thing I'm seeing some hints of are some dikes.
That's better video. I can hear him.
Survey 1, this is now.
My mind playing tricks on me, but
how do you think you're moving?
Survey 1, I still can't hear you. Wait one, please.
Doing pretty good here.
Well, I'll let you know if I do. I don't see anything in the field of view right now that looks like it.
Try to keep an eye on it.
Yeah.
Get the timing down.
Me neither.
Okay, survey.
Yeah, I would be looking for horizontal fractures, maybe columnar jointing. If we have a wide enough dike.
We started off with a short move.
For folks who may be listening don't know what a dike is, it's a vertically or high angle intruded igneous or magma body that cools underground. And often these things, when they cool adjacent to the rocks that they intrude between, they tend to fracture perpendicular to the walls of fractures that they intrude, and therefore they have what looks like columnar blocks that are oriented perpendicular to the walls of the dike.
I think you might be moving, co-pilot.
And usually they're darker.
Starting to think so too.
Than the material that they intrude.
Well,
not always, but sometimes.
Yeah. Okay, pilots, we have 10 meters left of that one ship move.
Okay.
One bit of information I forgot to give you: in a 30-meter move to 270, the inclination was also 30 meters.
Okay.
So it's about a 45-degree.
Copy that.
Yeah, pilot, I'm wondering if we could get a zoom on some of the white areas on the left.
On the left, okay. Heading that way.
Just to get a look at the surfaces of these rocks.
So actually, I have a question for you.
Go ahead, pilot.
This dive was called a mud volcano. What indicated that it was a mud volcano?
Well, it was initially called a mud volcano and a scarp because we weren't sure. This was based on 60s U.S. Navy SAS bathymetry using satellite fixes for navigation. So the features that we saw were located quite differently once we actually mapped this area, and the only thing that we saw that looked really, exciting to dive on was this scarp. There was a lump of stuff that might have been what the Navy data showed as a mound at the base of the scarp, but that's probably just material that fell off the scarp.
I see.
How about looking real close at that white patch in the just above the left-hand laser, if you can?
I'll just spin that way a little.
Right.
We had a shrimp, but he took off.
Oh,
okay,
sorry.
Video, you can go in.
Oh, and a nice focus on that. Well, this certainly looks like secondary deposits on the surfaces. Yeah, secondary deposits on the surfaces of rocks. I'm wondering if our videographer sees any small critters anywhere in the screen that we could take a look at.
Thank you, Nav. I do not. I see a very slight
Just
red
more of those
dot,
filaments, very tiny filaments or fuzzy things on the rocks. Yeah, video doesn't see anything biologic. Thank you, pilot.
You're welcome. Yeah, that was good.
So I think we can keep going up. If people at home would like to take a look at your feed too, which is the Sirius feed,
just a little down.
You can see D2, the remotely operated vehicle, just climbing up a sort of V-shaped scarp. But it looks like maybe our videographer found a critter.
Nope, sorry.
Or something different.
Nothing.
Possible coral, not turned out to
And
be
now
more
I'm told
white staining.
nothing.
Right.
It's interesting when our geologist is searching so vigorously for the biological. You go, girl.
Well, you know.
She's trying to be crowd-pleasing.
We have to be magnanimous.
Co-pilot, you want to note all the comps in the log real quick?
Yeah.
They're getting, a couple are a little low. We don't want to be surprised later. Try to remember what they are.
Copy that. It's been 22 since I sat down, but yeah.
So, Deb, I see that you're commenting in the event log that this
I don't
is
know why that
fracture
one
looking.
I guess that one we did.
Would you mind explaining what that
swap,
means?
So it's not as
for us non-geologists.
Well, I think when I was just about to write, it also actually looks like perhaps there's some jointing if you kind of tilt your head in the right direction. When you look at this outcrop we're looking at, as we're sort of moving off of it right now, you can see that even though it looks like outcrop is in place, it doesn't look like it's fallen down the slope. You can see lots of little cracks in the rock. And so you can really see that those are fractures, showing that this, in other instances we might call these cooling cracks or something like that, but I think that this is more that these are older rocks and they've just lived through lots of events.
Beautiful
so
view.
They're just broken up, but they're still in place.
Thank you, Deb.
Yeah, totally agree with you, Deb.
And so before, when I was saying that this looked similar to Hadal Ridge, I wasn't so much talking about the color of the rocks, but the shapes of these.
Yes, you're right.
What looks like a mini mountain range.
Yeah, with steep points.
Yeah, is that normal?
Normal. Well,
has that been seen before?
Yes, depends where you are, of course.
But we just happened to find this little ridge to follow.
This
dead center due west and Sirius.
This rock face looks exactly as you described. That it is a series of little ridges and little chutes or indentations.
Yeah.
To me and to anybody in Hawaii looking at this, it looks like the steep face of the windward side of the Ko'olau Mountain on Oahu, and that is formed. That was formed as a consequence of a monster landslide of one half of the eastern volcano that makes up the island of Oahu,
but it was a very slow move.
which is made up of two volcanoes. So the eastern one, half of it slumped off
close to the end.
right about at the middle of the volcano and fell into the ocean to the northeast of the island. And what's left behind is a very steep poly or scarp, but that scarp is looks like if you had a series of ropes draping of really fat ropes draping over a
Okay,
table, you would see a series of like huge corduroy ridges.
Where are you looking?
Left edge.
And that's pretty much what we're seeing
Left
here.
bottom corner.
Top corner.
So there's something in the left bottom corner. Is it a barnacle?
Just interesting shape. Rocks.
I love barnacles.
Well, I'll pan around for a minute at this zoom.
A lot of white
variety.
encrustation on these rocks. I like probably